An ambiguous image is one where the image stays the same, but our percept of the image changes. Could it be one thing or another? We often talk as if an image and our perception of that image are the same thing, but they're not. Light energy entering your eye is sensed by photoreceptor cells in the retina. Those photoreceptors transform the light into a format that the brain can understand. We call that format neural signals, the brain's method for moving electricity from one point to another. Millions of neural signals move from your eye to your brain every second. Most of those signals are sent via the midbrain to an area in the back of the brain called the visual cortex, located in the occipital lobe. From there, the neural signals travel to many different parts of the brain. Each area in the brain responds to different information extracted from the image. The brain first has to decide what is the object and what is the background. And this isn't always as simple as it sounds. Imagine, if you will, a blank screen, and you draw a line in one portion of it. That line forms a boundary. The line divides your perception of space. If we add another line here, we have what's known as Rubin's vase illusion. When you look at it directly, sometimes in the center you'll see a vase standing there as if by itself. And then you'll see the background appear as two different faces. So your perception is always switching, either the vase or the two faces. It's not as if the image itself has changed, only the way your brain constructs the world. It's as if our world is composed of these objects and we're always struggling to make one part of the scene real and the other part the background. This is particularly true with this classic Escher illusion. Here is a famous painting of his called Sky and Water. In this painting, near the top, you see primarily birds, and on the bottom, you see primarily fish. What he has done is to add detail to the birds on the top and add detail to the fish on the bottom. And by adding the detail, you've given those forms sort of an objectness that make them become more vivid and more object-like. Less obvious than Rubin's vase or Escher's birds and fish. Look at this representation of a cube. There are at least 3 ways of interpreting this shape. Most people see it as a cube with the lower front corner nibbled out. Got it? Now, look for a cube-shaped room with a small cube intruding into the far corner. Got it? And number 3 is a complete cube with a small cube joined to its near corner, at rather an odd angle. This one's a bit strange, not so easy, but it is there. Got it? The object stays the same, the world stays the same, but our brain wants to give it one of 2 or 3 different possible interpretations. It's not stable, not because the image isn't stable, it's because our brain is trying to understand it in different ways. So take a look at this object, attributed to 19th century crystallographer Louis Albert Necker. Not much to get excited about here, but which way is it facing? Most people first see it this way, as if the lower right face is coming out towards you and downwards. But this way of looking at the cube, with the arrow emerging from the top left forward-facing square, which appears to be projecting upwards, is just as valid. Look at it again without the arrows, and you'll probably find that your brain is switching from one angle to the other every few seconds or so, without you having to do anything. Your brain is trying to make sense of the conflicting messages it's receiving. So at a certain point, we're not sure exactly when, the brain switches to the other view, which may be more satisfying or more stable. Of course, one view isn't more stable than any other view, but your brain doesn't know that. But there's a twist, literally. If we rotate the cube as if it's suspended from an invisible thread, the ambiguity continues as before, but now something else is happening too. Watch the rotating cube and just relax. Is it rotating anti-clockwise or clockwise? Or did it just change direction? Watch some more. Pick a corner. One moment it's going away from you. The next, it's approaching you. Did you consciously make it switch directions, or did it just seem to happen automatically? Of course, when the cubes rotate from one direction to another, it has to correspond to something that's going on in the brain. Perhaps it's a set of networks where one network dominates in one condition and another network dominates in another. But we don't know the specifics of such networks. In fact, when we do understand the specifics, we'll go a long way towards understanding what perception is and how consciousness occurs. Now, Necker's rotating cube is intellectually intriguing, but here's an image that has caught people's attention more directly. Kayahara's spinning dancer. If you watch the dancer, it'll seem to spin either in one direction or the other. For some people, it'll stay spinning in that direction for a long time. But if you watch it long enough, it'll reverse in the other direction. Why does this happen? Well, the information that's available in the image tells us that there's a dancer spinning. Because we don't have detail, we could easily interpret it as spinning one direction or the other direction. The information would make sense either way. The brain has to make a decision. So with the silhouette, we have a lack of information. It could be interpreted either direction. But what happens if it's something that's a familiar object with information? Here we have a mask. One that would be staring right out at you and to the audience. But look what happens when it spins. It starts rotating to the right, but suddenly the face itself looks like it's spinning to the left. Why is that? You thought you were looking at a regular mask, but actually you were looking at the inside of a mask, and our brain flipped it so it was actually seemed like it was looking right out at you instead of looking away from you. Here's another way of playing with the same type of illusion as the hollow mask, which is Gerry Andrus's wonderful dragon illusion. Here the dragon's faces are inwards, but you would never guess it from looking at this picture until you see the object rotate. And once it starts moving, suddenly we have different types of information that are available. And the faces seem to be moving in an opposite direction of the whole rotation. It's really compelling to look at, and I could look at this forever. It's always intriguing and it always holds up, and it's always surprising. And talk about surprising, look at this antique fork. Look closely. Are there 2 tines or are there 3? In order to figure it out, we have to understand what happens when we take small features and combine them to make a global percept. We'll talk about this illusion and others like it in our next episode.